3.4, basic concepts of probability. We start with the union rule for probability, and this should look familiar to you because we've seen it in a different context. The last time we saw it, it was not probability, it was just like talking about the number, but I still look at it as this is a double equals a single plus a single minus the opposite double. The doubles are interchangeable, so you could reverse it and say this is and this is or if you want, but it's really the same thing as what we've seen before with n instead of p. But now we're talking about probability. Remember from before, we know probability is part over total. Always, always, always. That's always going to come back. Probability is part over total. Number 1 says, if a single card is drawn from an ordinary deck of cards, find the probability that it will be red or a face card. And so what I like to do is I like to abbreviate. We want red or a face card. And so I might write it like this: probability of red or a face card, like this. R or F. R union F. Remember, I read that union as the word or. So when you see the word or, that's kind of an important signal that we're going to do union. But we can use this union rule and set it up as a single plus a single minus the opposite double. And what I mean by that is if we're looking for union, the opposite double would be the intersection, like that. And so to answer this question, you have to know some stuff about cards. You have to know, why did I put an E there? That's not supposed to be an E. What is that supposed to be? That's supposed to be an R, sorry. You have to know how many red cards there are. Remember, probability is part over total, but the part in this case is how many reds are there? How many red cards are there? 26 out of how many total cards are there? 52, right? Good. And then for the face cards, how many face cards are there? I heard 6, I heard 12. Which is it? There are 6 black face cards and there are 6 red face cards, but all I'm talking about right now are face cards. How many face cards are there? Okay, those of you that said 6, you're thinking, and I know what you're thinking. That's a good thought. All right, but that's going to be what we do here. Probability of R and F means I want to know the probability that it's a red card and it's a face card, or that it's a red face card. So how many red face cards are there? There are 6, right? Out of 52. And so the probability of red or a face card is going to be 26 over 52 plus 12 over 52 minus 6 over 52. 26 plus 12 is 38. Minus 6 is 32. We get 32 over 52. And that's pretty good. Probably going to be better if you can reduce that. 8 over 13. Or my general rule is if it's easy to reduce, reduce. If it's not easy to reduce, use a calculator. So if I did 32 over 52, about 0.6154. I like 4 decimals. 6154. Now think about what we did and the reason why we subtracted 652. And some of you guys were kind of ahead of the game already. If I just add up the red cards plus the face cards, I've counted some of the cards twice. Like a King of Hearts. A King of Hearts is a red card, but a King of Hearts is also a face card. So I ended up counting that card twice. I'm going to have to subtract off the ones that I counted twice. And it turns out that I counted 6 of them twice, so that's why I'm subtracting off the 6 of them that I counted twice. That's what this union rule does. Number 2, suppose 2 fair dice are rolled. find each probability. So over here is this picture. This picture is showing every single possibility that could happen. You could roll a 1 and a 1, or a 1 and a 2, or a 1 and a 3, and so on and so on and so on. You should be able to count up and see that there are 36 possible outcomes for these dice. It's kind of important that one of them's red and one of them's white, so you can tell a difference between rolling a 1-2 and rolling a 2-1. If they were the same color, you wouldn't really know the difference between a 1 and a 2 and a 2 and a 1. So they're a different color. That's significant. But when they're two different colors like this, you've got 36 different outcomes. So we want to find the probability that the first die shows a 2, or the sum of the results is 6 and 7. Okay, so I'm going to write it like this: probability that the first one is a 2, or the sum is 6 or 7. All right. So that looks like the union rule. That looks like the union rule. We can say that's going to equal the probability that the first one is a 2 plus the probability that the sum is 6 or 7 minus the probability of both of those things happening. So what I would do is just kind of look at this picture and count. The probability that the first one is 2, well, the first is 2, looks like this row right here. That's kind of hard to see. But this row has 6 possibilities. So the probability of the first one being 2 is 6 out of the total number 36. How about the sum of 6 or 7? If the sum is 6 or 7, then you're looking at, okay, sum is 6. Sum is 7. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see 11 different possibilities where the sum is either 6 or 7. Now, did I count any of those twice? See how there's 2 of them that I highlighted in yellow and circled in green? There are 2 different outcomes that did both of those things. And so I'm going to need to subtract off that overcount. And that's what the union rule does. 6 plus 11 is 17, minus 2 is 15. That answer is going to be 15 over 36, whatever that reduces to. What does that reduce to? 5/12 is probably the best answer. I've got here that's about 417. Questions? Sum of the results is 11, or the second die shows a 5. So probability that the sum is 11, or the second one is a 5. So again, using the union rule, sum 11 plus second is 5 minus probability of both. I would just look at this picture. Sum of 11, I think there's just 2 of them. Sum of 11 is 2 out of 36. Second one is a 5. Second one is a 5 is these 6 right here. So that probability is 6 out of 36. And then you have to subtract off anything that you've counted twice. How many results are in both of those circles? Just 1. So the probability that both of those things happening is 1 out of 36. 2 plus 6 is 8, minus 1, you get 7/36. Can't reduce. That's about 0.194. Complement rule. I like it better like this. And that's, students get confused by this, but it's not trying to be hard, all right? The probability that I wear a blue shirt on a given day is 0.8, okay? The probability that I wear a blue shirt on a given day is 0.8, all right? So what's the probability that I don't wear a blue shirt? 0.2, right? That's a pretty easy thing to think of. That's exactly what that formula says. That's exactly what that formula says. It's just 1 minus 0.8 was 0.2. You did that in your head. That's all the complement rule says. The probability of not blue equals 1 minus the probability of blue. So don't get confused by the complement rule just because you're confused by the notation. That little apostrophe means not. That means complement. If a fair die is rolled, what is the probability that any number but 5 will come up? I think this is overly simplistic, but they're saying probability that it's not 5. And so probably the easiest way to do this is to look at the sample space. When you roll one die is this. And so if I don't roll a 5, it looks like the probability of rolling something else would be 5 out of 6, right? And that's probably the best way to do it. But what they're talking about right after the complement rule, they probably want you to use the complement rule in this way. The probability of rolling a 5 is 1/6. So according to the complement rule, 1 minus that would be 5/6. I think it's a lot easier just to look at the sample space, though. Either way, 5/6. A lot of these problems, you're going to have two different ways of doing it. Either you do it directly and find 5/6 by counting, or you do it indirectly and find 5/6 by subtracting off what you don't want. You find what you do want directly, you subtract off what you don't want. Two fair dice are rolled. Find the probability that the sum of the numbers rolled is greater than 3. So probability that the sum is greater than 3. That is not the union rule. We don't have to do this plus this minus this. That's not the union rule. I think the easiest thing to do is probably just count. The sum is greater than 3 is going to be like every single one of these things. Okay? Right? All of those results, how many of them are there in that circle? 35? 33? How many of you counted up to 33? I bet you didn't count to 33, did you? I bet you used the complement rule and you didn't even think about it. You probably said, well, there's 3 not in the circle. 36 minus 3 is 33. You probably didn't even think about it. All right, you used the complement rule and didn't even think about it because you knew that it was going to be 36 minus 3 was 33. That's what you did. All right, so the complement rule says it's 1 minus the probability of the sum being less than or equal to 3, or 36 minus 3 over the total. That's 33 over 36. So you probably did it indirectly without even meaning to. The direct way would have been literally to count. I don't want to do that. Oh, by the way, that reduces to 11/12, and that's about 0.917. I would take any of those 3 answers. I'm not overly concerned with reducing fractions. Question? Like this? Well, if it's not greater than 3, then it could be equal to 3, right? You've got 2 different possibilities. You've got the sum's less than 3 or the sum is equal to 3, right? That's what they're talking about. Any one of those things is not greater than 3. right? Greater than 3, the smallest number have to be 4. Okay, good question. Odds. Here's another thing that students aren't very good at that's not very hard. All right, open your mind and focus here. We're so good at probability being part over total that when the script is changed slightly, can't handle it. All right. Here's the formula for odds. But instead of part over total, what I think of this as is part over non-part. I think that's a little bit easier to process. And so you've got a couple of different formulas for that, but essentially when I'm thinking about odds, I'm thinking about part compared to non-part. So here's an example. If the probability of something is 2/7, most people understand probability. Part over total, you got it. But as soon as I say odds of that same thing, people shut down. If the probability of an event A is 2/7, then the odds are 2 to 5. And think about where that 5 comes from. Okay. 2 is the number of things that happen that I'm talking about. 5 is the number of things that I'm not talking about. 2 plus 5 happens to add up to 7, right? That's how this is going to work. So let's do a different example. If the probability of some event is 11 over 17, then the odds of that event will be 11 to 6. Okay, I'm not really talking about a fraction. I don't really care about a fraction. You'll see if you ever go to like the racetrack and bet horses, you'll see it written like this, 11 to 6. That makes more sense to me. But that's what I'm talking about when it's odds. It's part to non-part. I don't see the total number 17 in that problem at all. Okay. So number 5, the probability of rain is 1/3. Probability of rain is 1/3. What are the odds of rain? Part to non-part. 1 to 2. Those two numbers have to add up to 3 because that's the total. Whatever you're looking at, rain, plus whatever is not rain, has to add up to 3. Or you could write it as 1 to 2 if you want. I kind of prefer that way, but they're both the same thing. When you write it as a fraction, it gets confusing, and we kind of think that that's the same as probability, but it's not. All right. Part B. The odds my horse wins the race is 7 to 2. What's the probability my horse wins the race? 7 over 9. Very good. Because probability is part over total, odds is part to non-part. 7 plus 2 is 9. That must be the total. All right, that's a little bit tricky. I know students really struggle with that. The odds that a particular package will be delivered on time are 25 to 2. So the odds, let's just say P for package, is 25 to 2. Find the probability that the package will be delivered on time. So probability that the package is delivered on time. Part over total, 25 over 27. Okay. Find the odds against the package being delivered on time. So we want odds that the package is not delivered on time. Now the part becomes the non-part, and the non-part becomes the part. It just flips upside down. If the odds were 25 over 2, then the odds against are 2 over 25. The total is still 27, right? The total is still 27, but the odds just, you have to reverse. And both of those things say the same thing. All of those numbers right there, come on now, can't get it. All of those numbers say the same thing. Number 7, if the odds in favor of a particular horse's winning a race are 5 to 7, so odds of winning are 5 to 7, what's the probability? Feels like we already did this. It's the probability of winning 5 to 12. 5 to 12. Probability distribution. A probability distribution is a table listing all possible outcomes of an experiment and its corresponding probability. So a simple example of this would be like a coin flip. What's the sample space for a coin flip? Heads or tails, right? One coin, flip it, either it's heads or it's tail. Fair coin, whatever. What's the probability of this outcome? Heads? 0.5. What's the probability of this outcome? Tails? Also 0.5. So a probability distribution is just a table that shows all of the things that could happen. So you're going to say, all right, usually you'll say like X and the probability of X. X is your variable, or in other words, what could possibly happen. And in this case, what could possibly happen is either heads or tails. So X could either be H or X could be T, and then the probability of either one of those things is 0.5. That's about as simple as I could possibly make a probability distribution. But it's just a table of everything that could happen. So it's going to get more complicated here. Construct a probability distribution for the sum of the numbers showing when two dice are rolled. So think about the sample space. We're talking about the sum, right? So you add those two things together. What's the smallest a sum could be? 2. 1 plus 1 is 2. And so you could get 3, 4. What's the highest number? 12. Good. That's the sample space. That's everything that could happen in this problem. So you can write your table going up and down or sideways. Kind of depends on how much space I need. We wrote this one going up and down. Let's write this one going sideways. All right. So X and P of X. X is your variable, and X could take on any value in the sample space. X could take on 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. But we need to calculate the probabilities for each of those possibilities. All right. So the probability of rolling a 2, part over total, right? Probability, part over total. It's just 1 out of 36. Probability of rolling a 3. Well, that's just these two right here. That's going to be 2 out of 36. And I'm not worried about reducing fractions here. Probability of rolling 4. Well, that's these 3 right here. 3 out of 36. Probability of rolling 5. It's these 4 out of 36. 6. Whoa, where are we at here? That's, how many is that? 5? 5 out of 36. 7. There are 6 different possibilities out of the 36 that could add up to 7. And then there are 5 possibilities that could add up to 8. And there are 4 possibilities that could add up to 9. And there are 3 that could add up to 10. 2 that could add up to 11. And 1 that could add up to 12. That's a probability distribution. Can you tell which outcome is most likely to happen? 7 is the one that's most likely to happen. But a probability distribution, it's everything that could happen in this problem. Number 9, Susan is a college student who receives heavy sweaters from her aunt at the first sign of cold weather. Susan has determined that the probability that a sweater is the wrong size is 0.47. The probability that it's a loud color, loud meaning bright, is 0.59. And the probability that is both the wrong size and a loud color is 0.31. Find the probability that the sweater is the correct size and not a loud color. So this is a tough question because it's got so much stuff going on, and you got wrong size, you've got a correct size, you've got to really nail down specifics of this problem. Okay, be hyper focused on specifics. The first thing I like to do is write down my given information and kind of take it out of the context of a story problem. So the probability that it's the wrong size is 0.47. And the probability that it's a loud color is 0.59. And the probability that it is both the wrong size and a loud color is 0.31. All right. Now, you might be able to use the union rule. Sometimes you can use the union rule, but only in very specific cases. We talked about yesterday or the day before, if you can't use the union rule, the only other option you have is to draw a Venn diagram. And that really works a lot. And sometimes people will refuse to draw one or forget to draw one or whatever, but I think that's probably going to be the best thing to do in this case. All right. What's confusing is when it says correct size, we don't want to make another variable. We don't want to use C for correct because we already have wrong size, and we can say the correct size is just not wrong. And so what we want to do is say not wrong and not loud, right? So that's what we're trying to find. Probability that it is not wrong and not loud. This does not fit the criteria for the union rule. I can't use the union rule here. The union rule would be helpful if I needed to find the opposite double, W or L. That's not what I'm finding. That's not what I need. So if you can't use union rule, probably going to do a Venn diagram. So let's draw a Venn diagram. I've got two sets, wrong color, or wrong size, sorry, and loud color. Don't forget to draw the box. If you don't draw the box, you're not going to have all four of your subsets, all four of your regions here. So keep it consistent with last lesson. Go to the overlap. We've got W and L is 0.31. That's where you would want to start. We know wrong and loud color is 0.31. So then work backwards off of that, like some of our problems from the homework. If the probability of wrong is 0.47, then that must mean that subtract 0.47 minus 0.31 is 0.16. That's got to be 0.16 right there. You're subtracting to make that circle add up to 47. Now it works. Likewise, you're going to use the subtraction. 59 minus 31 is what? 28? 28 must go here. Okay, again, I did 47 minus 31 was 16. I did 59 minus 31 was 28. Now, I've got four regions, but only three labeled. But what's going to help me in this problem is I know that all four of them add up to 1 because we're talking about probability this time. They don't have to tell me that. That's always going to be the case. And so I suppose if I did 1 minus 0.16 minus 0.31 minus 0.28, that's 0.25. I know that it must be 0.25 outside of the circles. If you can label all of your parts, then you should be able to answer anything that's possible. Okay. And we need not wrong and not loud. Not wrong and not loud is hard to visualize in this picture. I'm not very good at it, and so I don't even try. I will look at my symbols here, And I will look at my numbers in my diagram. And if I think about not wrong, so tell me the numbers that are not inside the W circle. 0.25 and 0.28, right? We're going to intersect that with not inside the L circle. So that's 0.16 and 0.25. If we intersect those two, we look for what's in common. That's going to be 0.25. 0.25 is in common. We're just talking about the region that's outside of the circles. Part B, find the probability that the sweater is the correct size or is not loud. So correct is not wrong, or is not loud. Not wrong or not loud. Again, I don't think I have the right information for the union rule. I could maybe figure out the right information for the union rule, but I think it's much easier to just use my diagram. Not wrong. Look at what's not inside the W circle. Not wrong. That's 0.25 and 0.28. We're going to union that with not inside the L circle, which is 0.25 and 0.16. If we're going to union that, we mean join. Join means take them all. 0.25 plus 0.28 plus 0.16. You wouldn't take the 2.5 twice. Add those up. 2.8, 2.5, 1.6 adds up to 0.69. That's not wrong or not loud. If you had to color that in, you're coloring in the region with the 0.25 and the region with the 0.28 and the region with the 0.16. That's basically everything except for the football in the middle.